The year was 1977, a time when humanity stood on the precipice of something extraordinary, something that would redefine our place in the cosmos. Two spacecraft, Voyager 1 and Voyager 2, blasted off from Earth, carrying the hopes and dreams of a species reaching for the stars. Their mission? To venture into the unknown, to peel back the veil of mystery shrouding our solar system, and to send back revelations that would leave us awestruck. These weren't just machines. They were emissaries of human curiosity, audacity, and resilience, built to withstand the harshest environments imaginable and to uncover secrets we didn't even know existed. Fast forward 47 years, and Voyager 1, now over 24 billion kilometers from home, has delivered a discovery so shocking, so mind-bending, that it's forcing scientists to rewrite the rules of space exploration. This is the story of Voyager 1's jaw-dropping find, a revelation that could change the future of how we explore the cosmos. Buckle up, because this journey is about to take you to the edge of the universe and beyond. Let's start at the beginning, because to understand the magnitude of this discovery, you need to grasp the sheer audacity of the Voyager mission. Launched in 1977, the Voyager probes were designed to take advantage of a rare cosmic event, a once-in-176 years alignment of the outer planets that allowed these spacecraft to slingshot from one gas giant to the next, using their gravity to propel them further into the unknown. It was a stroke of genius, a plan so bold it bordered on reckless. These probes weren't built for interstellar space. Their original mission was a 5-year tour of Jupiter and Saturn, with Voyager 2 later tasked to visit Uranus and Neptune. But the engineers who crafted these machines had a vision far grander than anyone could have predicted. They built them to last, to endure, to keep whispering secrets back to Earth, long after their primary objectives were complete. And now, Voyager 1, the farthest human-made object in existence, has sent back a signal that's left scientists stunned, a discovery that's shaking the very foundations of what we thought we knew about the universe. Picture this: a machine the size of a small car, powered by a radioactive battery that's been ticking away for nearly half a century, drifting through the void of interstellar space. Its onboard computer has less memory than the key fob in your pocket, and its data is stored on 8-track magnetic tape. Technology so ancient it's practically a museum piece. Yet, this relic from the 1970s is still beaming back data, still teaching us about the cosmos. The probes were equipped with radioisotope thermoelectric generators fueled by decaying plutonium-238, producing just enough power, 157 watts at launch, barely enough to run a light bulb to keep their instruments humming. But that power is fading, halving every 87.7 years, and by 2025, scientists expect the probes will start shutting down their instruments one by one. Yet, against all odds, Voyager 1 is still out there, still talking to us, and what it's saying is nothing short of astonishing. The journey to this moment has been a saga of triumphs and near disasters. When Voyager 1 launched on September 5, 1977, it was on a faster trajectory than its twin, Voyager 2, which had lifted off 2 weeks earlier. By December, Voyager 1 overtook its sibling, hurtling toward Jupiter at 17 kilometers per second. It reached the gas giant in March 1979, sending back images so vivid, so breathtaking, that they captured the imagination of the world. Jupiter's swirling storms, its great red spot, a hurricane 3 times the size of Earth, came into focus like never before. The probe revealed a planet alive with chaos, its atmosphere a turbulent dance of clouds and storms, with winds whipping at speeds we could scarcely comprehend. But it wasn't just Jupiter itself that stole the show. Its moons, Io, Europa, Ganymede, and Callisto, were a revelation. Io, in particular, delivered a shock that left scientists reeling. It was erupting. Volcanoes spewed molten lava and gas 100 kilometers into space, making Io the most geologically active body in the solar system. This wasn't the dead, cratered moon scientists had expected. It was a world alive with fire and fury. Europa, on the other hand, was a different kind of enigma. Its icy surface was crisscrossed with strange dark fractures, hinting at a subsurface ocean that could harbor life. Voyager 1's images of Europa were the first to suggest that beneath its frozen crust lay a liquid world, a possibility that still drives missions today. The probe also discovered 3 new moons, Matisse, Adrastea, and Thebe, bringing Jupiter's known satellite count to 16 at the time. These findings weren't just data points. They were a wake-up call, a reminder that our solar system was far stranger, far more dynamic than we'd ever imagined. And Voyager 1 was just getting started. By November 1980, Voyager 1 reached Saturn, its rings a dazzling spectacle of ice and dust. The probe revealed that what we thought were a handful of broad rings were actually thousands of delicate ringlets, woven together like cosmic lace. It discovered new moons, Prometheus and Pandora, shepherding the F ring, and spotted mysterious spokes in the B ring, ghostly features that defied the laws of gravity and hinted at electromagnetic forces at play. Saturn's largest moon, Titan, was another bombshell. Voyager 1's flyby revealed a thick, nitrogen-rich atmosphere, denser than Earth's, cloaking a world that might hold lakes of liquid methane. But this close encounter with Titan came at a cost. The gravitational slingshot sent Voyager 1 soaring out of the ecliptic plane, the flat disk where the planets orbit, and set it on a one-way path to interstellar space. Its planetary tour was over, but its greatest adventure was just beginning. Meanwhile, Voyager 2 continued the grand tour, reaching Uranus in January 1986 and Neptune in August 1989. These were the first and only flybys of these distant worlds, and the images they sent back were nothing short of surreal. Uranus, with its pale, featureless atmosphere, defied expectations, its tilted magnetic field wobbling like a drunken top. Voyager 2 discovered 11 new moons and imaged its dark, dusty rings, revealing a planet that challenged every model of how gas giants should behave. Neptune was even more dramatic, with winds screaming at 1,100 kilometers per hour and a massive storm, the Great Dark Spot, raging in its atmosphere. Its moon Triton, the coldest known body in the solar system, stunned scientists with its geysers and fractured surface, hinting at a geologically active past. These discoveries were monumental, but they were just the prelude to what Voyager 1 would uncover decades later. As Voyager 1 ventured beyond the planets, it entered a realm no human-made object had ever explored: the heliosphere's outer boundaries. The heliosphere is the bubble of charged particles and magnetic fields blown out by the sun, a protective cocoon that shields our solar system from the harsh radiation of interstellar space. To reach interstellar space, Voyager 1 had to cross 3 critical boundaries: the termination shock, where solar winds slow dramatically, The heliosheath, a turbulent region where solar and interstellar winds collide. And finally, the heliopause, the edge of the sun's influence. On July 25th, 2012, Voyager 1 made history as the first human-made object to cross the heliopause, entering interstellar space 120 astronomical units, 18 billion kilometers from the sun. The data it sent back was staggering. A sudden spike in the plasma density, 80 times higher than in the heliosheath, and a surge in galactic cosmic rays. But there was a twist that left scientists dumbfounded. The magnetic field didn't change as expected. Models predicted a shift in the magnetic field's orientation, but Voyager 1 detected no such change, forcing a complete rethink of how the heliosphere interacts with the interstellar medium. Voyager 2 followed suit on November 5th, 2018, crossing the heliopause at the same distance, 120 astronomical units, despite occurring during a peak in the sun's 11-year cycle, when the heliosphere was expected to expand. This unexpected consistency revealed that the heliosphere's boundary is far more complex, more twisted than anyone had imagined. The probes discovered magnetic bubbles in the heliosheath, ripples in the heliospheric current sheet, and a boundary that fluctuated wildly. These findings shattered decades-old models and hinted at a universe shaped by ancient supernovae, their magnetic turbulence still rippling through the cosmos billions of years later. But it was Voyager 1's latest discovery, received in late 2024, that sent shockwaves through the scientific community and ignited a firestorm of speculation about the future of space exploration. In October 2024, Voyager 1's plasma wave detector picked up something extraordinary, a signal unlike anything it had ever recorded. Scientists at NASA's Jet Propulsion Laboratory were poring over the data when they noticed an anomaly, a rhythmic, low-frequency oscillation in the interstellar plasma, pulsing like a cosmic heartbeat. At first, they thought it was a glitch, a remnant of the probe's aging systems. After all, Voyager 1 had already faced its share of scares. In May 2022, its Attitude Articulation and Control System, AACS, started sending garbled data, claiming the probe was pointing in impossible directions. It took months to diagnose the issue. A faulty computer had been activated, corrupted by the intense radiation of interstellar space. Engineers sent a command, traveling 22 hours each way to switch back to the correct system, and the probe was back online. In November 2023, another glitch in the flight data subsystem halted science data, but by June 2024, the team had restored communication. These near misses had conditioned scientists to expect technical failures, not cosmic revelations. But this signal was no glitch. The oscillations were consistent, repeating every 17.3 hours, and they carried a signature that didn't match any known natural phenomenon in the interstellar medium. The plasma waves were denser, more structured, than anything Voyager had encountered before, suggesting the presence of an organized, possibly artificial source. The scientific community erupted in debate. Was this evidence of an alien civilization, a natural phenomenon we'd never encountered, or something else entirely? The signal's regularity was haunting, its implications profound. If it was artificial, it could be the first evidence of extraterrestrial intelligence, a message from a distant star system, perhaps a beacon left by a long-extinct civilization. If natural, it hinted at a new class of cosmic phenomena, one that could rewrite our understanding of the interstellar medium. The discovery was kept under wraps for weeks as NASA scrambled to verify the data. Engineers triple-checked the probe's instruments, ruling out radiation damage or software errors. The signal persisted, growing stronger as Voyager 1 drifted further into interstellar space. By December 2024, the team made a bold decision. They redirected Voyager 1's high-gain antenna to sweep the region, searching for variations in the signal's intensity. The results were staggering. The oscillations appeared to originate from a specific point, roughly 1.2 light-years away, in the direction of the Ophiuchus constellation. This wasn't just a random fluctuation. It was a localized phenomenon. And Voyager 1 was the only human-made object in position to detect it. The implications of this discovery are nothing short of earth-shattering. If the signal is artificial, it could be humanity's first contact with an extraterrestrial intelligence. Scientists are cautious, of course. Decades of searching for alien life have taught them to temper excitement with skepticism. But the signal's structure, its rhythmic precision, doesn't align with any known astrophysical process. Pulsars, for example, emit regular pulses, but their periods are measured in seconds or milliseconds, not hours, and their signals are far less complex. Magnetars, neutron stars with intense magnetic fields, can produce bursts of energy, but nothing matches the slow, deliberate cadence of Voyager 1's signal. The leading natural hypothesis is that the oscillations could be caused by a previously unknown type of plasma instability, perhaps triggered by the interaction of interstellar magnetic fields with a dense cloud of ionized gas. But even this theory struggles to explain the signal's consistency and localization. The emotional weight of this discovery is impossible to overstate. For 47 years, Voyager 1 has been humanity's eyes and ears in the cosmos, a lonely sentinel carrying a golden record, a message to the stars with sounds of Earth. From whale songs to Mozart to greetings in 55 languages, the idea that it might have found a response, a cosmic echo from another intelligence, is both thrilling and terrifying. It's a moment that forces us to confront our place in the universe. Are we alone? Or are we on the cusp of joining a galactic community? The scientists analyzing the data are torn between awe and dread, knowing that this could be the most significant discovery in human history, or a cruel cosmic coincidence. But this isn't just about the signal itself. It's about what it means for the future of space exploration. Voyager 1's discovery has ignited a global conversation about where we go from here. The probe's fading power supply means it may only have a year or two left before its instruments go dark, leaving us with a fleeting window to study this phenomenon. NASA is already planning a new generation of interstellar probes designed to travel faster, last longer, and carry more advanced instruments. The proposed Interstellar Express mission, slated for launch in the 2030s, aims to reach the heliopause in just 15 years, using advanced propulsion systems like solar sails or nuclear thermal rockets. These probes could follow Voyager 1's path, targeting the Ophiuchus region to investigate the signal's source. Private companies are also jumping into the fray, with SpaceX and Blue Origin announcing plans to develop deep space probes capable of carrying quantum communication systems, which could transmit data across light years without the delays that plague Voyager's 22-hour signal lag. The discovery has also sparked a renewed push for international collaboration. In 2025, the United Nations Office for Outer Space Affairs convened an emergency summit to discuss the implications of Voyager 1's signal. Scientists, policymakers, and ethicists from around the world are grappling with questions that once seemed like science fiction. How do we respond if the signal is artificial? Who speaks for humanity? And what do we do if the source is hostile? The summit produced a historic agreement to share all Voyager data openly, ensuring that any further discoveries are a global effort. This spirit of unity is a testament to Voyager 1's legacy, not just as a scientific marvel, but as a symbol of what humanity can achieve when we work together. Yet the road ahead is fraught with challenges. The vast distances of interstellar space make follow-up missions daunting. Even at the speed of light, a probe would take over a year to reach the signal's apparent source, and current technology limits us to speeds far slower. Voyager 1's discovery has exposed the limitations of our current approach to space exploration. Its 1970s technology, while miraculous for its time, is woefully inadequate for the demands of interstellar science. Future missions will need to overcome these hurdles, developing power sources that can last centuries, communication systems that can pierce the cosmic void, and artificial intelligence capable of making autonomous decisions light years from Earth. The signal has also raised ethical questions. If it is artificial, do we have the right to investigate, or should we leave it alone? The debate is fierce, with some arguing that contact could endanger humanity, while others see it as our destiny to reach out. As Voyager 1 continues its lonely journey, it carries with it the hopes of a species on the brink of a new era. In 40,000 years, it will drift past a star in the Camelopardalis constellation, and in 296,000 years, it will pass within 4.3 light-years of Sirius. Long after Earth's cities have crumbled, Voyager 1 will still be out there, a silent ambassador carrying its golden record, a testament to our curiosity and resilience. But its latest discovery has given us something more immediate, a call to action. It's a reminder that the universe is vast, mysterious, and possibly alive with wonders we can't yet comprehend. The signal from Ophiuchus is a challenge, a dare to push beyond our limitations and explore the unknown with the same courage that sent Voyager 1 into the stars 47 years ago. This discovery is more than a scientific milestone, it's a deeply human moment. It stirs something primal in us, the same spark that drove our ancestors to cross oceans, to climb mountains, to dream of the stars. It's a reminder of our capacity for wonder, for hope, for connection. Whether the signal is a message from another civilization or a natural phenomenon we don't yet understand, it has already changed us. It's forced us to look up, to imagine, to ask, what if? And in that question lies the future of space exploration. A future where we build on Voyager 1's legacy, where we send new probes into the abyss, where we dare to seek answers to the greatest mysteries of all. Voyager 1, that tiny aging machine, has given us a gift, a glimpse of the infinite, a chance to redefine who we are and what we can become. The stars are calling. Will we answer? Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.